everyone, welcome back to the channel. I hope you are all doing well. Today we will be tackling a challenging problem from Geeks for Geeks, and it's categorized as a hard level problem. So let's dive right into the problem statement. And you know very well that Geeks for Geeks continuously was giving some easy level problems for consecutive 3 or 4 days, 3 days. So it is obvious that they will provide some hard level problem uh, consecutive 2 days. So the problem is longest prefix suffix. So this is a KMP problem, and it is one of the hardest DSA problem. So the problem says that give a string of characters, find the length of the longest proper prefix, which is also a proper suffix. Note, prefix and suffix can be overlapping, but they should not be equal to the entire string. Okay, and you can see the input is abab and output is 2. So I am not explaining here. I will go to the pen and paper by which I can make you a easy understand of this problem. So you are supposed to given a string and you have to determine the longest suffix as well as the prefix. Which will be the longest suffix as well as the prefix? Okay. So I will list down the prefix and I will list down the suffix. Okay. So what can be our prefix? Our prefix can be a, our prefix can be ab, our prefix can be abcd, abc, our prefix can be abcd, our prefix can be abcde, our prefix can be abcdea, abcdeab, as well as abcdeabc. These all can be our prefix. So one thing you should notice that our prefix cannot ignore the first element. Okay, so you have minimum one element which is the first element in our prefix. Okay, so this is the main condition, and I will repeat this line again and again because this is a very important line, that the prefix should start from the very first element of our string. Okay, then what will be the suffix? Our suffix can be c, bc, abc, eabc, deabc, cdabc, as well as bcdeabc, abcdeabc. These all can be my suffix, and please notice that your suffix must start from the end element of our string. Okay, the minimum suffix will be the end element. So you have to keep remember this line, that my prefix should start from the starting of my string and my suffix should start from the ending of my string. So my prefix cannot be constructed without the first element, and the suffix cannot be constructed without the last element of my string. So this is a very important point we have to remember. Now see, I have to return the longest string where prefix is equals to suffix. I have to return that. I have to return, you can say, the length. Okay, here I have to compare between a and c. Is a equals to c? No, these two strings are not equal. Is ab equals to bc? No, this is not equal. Is abc equals to abc? Yes, my abc is equals to abc. So my longest length will be 1 till now. ABCD is equals to EABC? No. ABCD is equals to DEABC? No. ABCDEA equals to CDEABC? No. ABCD equals to no. This is matching. Okay, this last element is matching. See, our last element is ABCDEABC, and last element of the prefix is ABCDEABC, and the last element of the suffix is ABCDEABC. These two are same. So you can think that you can return this, and why it is so much easy? That this is the same string which is given as input. So if it is given, then this is not the hard level problem. So the problem states that you have to ignore the last element of the suffix and the prefix. Okay, you have to ignore it and you have to return the longest one. So here in this example, the longest one is 1, so I have to return 1. Okay, now coming to one more example, AAA. In AAA, prefix suffix is a, double A, and I have to ignore the last element which is AAA, and same as suffix is a and double A, and double A. This is the suffix. Okay, so 2 is our output. So we have seen that the line that overlapping is possible in this case. Okay, we can overlap. So how it is overlapping? See, in this case prefix is double A, this is our prefix, longest prefix, and suffix is this much. Okay, so in this case we can say that this A is overlapping. So overlapping is allowed. Clear? I think this much is clear. So first brute force approach, what we can think is, we'll iterate throughout the string and we'll store that into a prefix and in prefix structure, and we can also store all the suffixes in the suffix structure, and we'll iterate throughout the prefix and also suffix, and we'll compare between each and every element of the structure. So what will be the time complexity of this approach? So we can say that to build all the prefixes, we can say the time complexity will be near about big of n square, and also to build the suffixes, the time complexity will be near about big of n square. And to compare each and every element, we can compare A to C, we can compare A to B, B to BC, A to ABC. So this will be the huge time complexity. Okay, so we cannot implement this logic because you will exceed the runtime. So we have to think something else, and there comes the logic is KMP. Okay, what is KMP? I will make you understand, and I will try my best to make you understand easily. So I will explain now KMP algorithm. Listen very carefully. Okay, this is a hard level problem, so you have to listen very carefully each and every word. So in this algorithm, what algorithm says that you have to declare two pointer. One is prefix pointer and another one is suffix pointer. Clear? Prefix will point at the very beginning of my string and suffix will point here. Okay, now question is, why I have to put my prefix at the very beginning? So I have already given you one example that in prefix, suppose this is the prefix array, all are the prefixes. In prefix, there is no such element where the beginning of the string is not there. So you must have to include this beginning A. In every string you notice that A is there. Okay, so it is obvious that we have to start with A. So I have put my prefix pointer here. Now what is the prefix pointer and suffix pointer? Suppose I have to take these two strings. I am taking these two example. Okay, my prefix pointer is pointing here and my suffix pointer is pointing here. So this is the intuition of my code. Prefix pointer will pointing to the string, to the prefix string which I have to compare, and suffix pointer is the pointer and it is the beginning of the string, of the suffix string, which I have to compare. So prefix is the first element and suffix is also the first element of prefix element and suffix element. Okay, so notice here, To become equal, my first condition is that I have to match prefix pointer and suffix pointer, and if it is matched, then I will move forward the prefix pointer also and the suffix pointer also, and I will check B is matched or not. So this is the process how I will compare. So here in this case I will compare this much. My prefix pointer is here and my suffix pointer is here. So at the very beginning, prefix pointer is here and my suffix pointer is here, and I have said that I have to compare the both string. So here I have noticed that these two are unequal, so I have to put here 0. Now I will, as I got that though both are unequal, so I will move forward the suffix pointer. Okay, something you have to remember in your mind, that you in examination hall you cannot just discover this intuition. So you have to keep in your mind that this is the process. This is the process that if this matched, if this not matched, then I will move the suffix only, and if this matched, then I have to move the prefix and suffix also. So I have moved my suffix here, and now my string is ABC. Now make prefix array and suffix array for ABC. My prefix can be A, my prefix can be AB, my suffix can be C, and my suffix can be BC. So here I have noticed that there is no such common element, so I can also put here 0 when my suffix is here, my prefix is here. So I have also got another mismatched. Now I will increase my suffix here and my prefix is there, and I will compare my this prefix and this suffix is matching or not. Okay, so I have noticed that this A and this A is matching, so I can say that from here prefix will start and from here suffix will start. Okay, now I will compare next element, so I will increase prefix here. My prefix is in B, and I also will move my suffix to the next element, and my suffix is here. Sorry, I have comparing these here only. So here this is a match, so I will put 1 here, and I will move the prefix here, and I have moved the suffix here. So I have got another match where the match is B, so I will increase another 2. And here I have noticed that there is a mismatch, and I have increased, before that I have increased my pointer is will be here, and these P and these S, these are mismatched, so I will simply return 0. Why return 0? Notice that ABC, ABT, there is no, please do by your own, that there will be no such substring where the prefix and suffix will be same. So I will put here 0. Sorry, I have put in I have already put here 0. Okay, now I will match, and I have moved P to again here because I have gotten one mismatch. So I have moved the P here, means prefix here, and I will compare this, and my suffix is here. I have compared this, then, and I have seen that this is a match, so I will increase at 1. So one thing you notice that ABC is, if it is your string, my prefix match will be ABC and suffix match will be ABC. So notice the indexation. So 0, 1, 2. So what will be the highest? Just my prefix is pointing at the last. My prefix is pointing at the last element of the prefix substring, prefix string. So this index plus 1 will be equals to 3, and this is my length of the longest suffix and prefix. So I have to, when I am putting here, I am putting the indexation where it is matching plus 1. Okay, now I have checked that a and a is equal, so this index plus 1. So I have moved prefix here and I have moved suffix here. I have also checked that b and b also matching, so I will this index plus 1 2. This c and c also matching. Before that I have moved my prefix pointer. Prefix is here. C and C also matching. So pointer 2 plus 1 3. Then I will move suffix here and I will move prefix here. A and A also matching. It will become 4. 3 plus 1 4. I have moved suffix here. I have moved prefix here. B and D is mismatching. Sorry. My B is my prefix is here now. My prefix is here now, not here. B and B is matching. So 4 plus 1 5. Now my prefix is here and my suffix is here. Here you can see that D and C is mismatching. So before going to the prefix here, you have to notice one condition here also. My substring is till now ABC A B D ABC ABC, and I have noticed that when I have encountered C, I got mismatched here. So I am telling you that this much and this much is not possible. Okay, this much and this much A B D. I'm writing again. A B C A B D A B C A B C. So I was comparing that my suffix is this much and my prefix is this much. So for this mismatching, I cannot say that I am not getting any common prefix and suffix. I cannot say, because to get prefix I have to include the first one and from the first, and to get suffix I have to include from the last. Okay, so I can exclude the mid part, okay, to matching this prefix and suffix. So as there is a mismatch, so I can cut the string from the middle. Before declaring that the whole string is a mismatch, before declaring it, I should cut from the middle and I should compare the first part and the second last part. So I have seen that the first ABC is matching with this much ABC. This is not needed that this full should be matched with this. I have to get any common one. So I have this common one, ABC and ABC. So I can say here, instead of 0, I can put it here 3, because I have got matching of 3 elements. So I am putting here 3. So what is this 3 element? ABC, ABC. So this index. So I can tell you that I can put my prefix here instead of prefix here. I can put my prefix here. Okay. Now question is, how you can do this comparison? How you can do this in algorithm? Suppose you got mismatch here, and these two part you are going to compare and you got mismatch here. So I have to decrease the prefix from here. Okay, I have to decrease the prefix. Like before I got mismatch here, so I can say this is my matching, this is my matching. I need to get any B, matching B here. So I got B here, but after that there is D, so it is not possible. I am going to this B here, and I have seen that after this B I got C, so this is a matching, this pair is matching. So after matching I decrease my suffix, I got A, and I also decrease the prefix and I got A, and this ABC and this ABC is matching. Okay, hope you understood. I have really worked hard, and in this summer I am like teaching you. This is very much difficult, and to teach you this kind of algorithm is very much difficult, and you have to visualize it. Okay, so what I am telling, that if I am getting any mismatch, I will go behind this and I will check if this kind of construction is here or not. And I have seen that B is here, and before C and before D the matching was B, and I have seen that B is here, but after B there is D, and after B there is C, so there is mismatch. So this B I will not consider. I will again decrease the prefix and I will come here, and I have seen that this after this B I have got C, and after this B I have also got C. So I will also decrease my prefix and suffix as well, and I have seen that I have matching A and matching A, and before that my prefix ends here, there is no such element, so my comparison ends here. ABC and ABC will be the longest common prefix and suffix. Clear? So after this much comparison, I will go here, and notice when I am here, I am telling here I am going this much comparison, my prefix comes here. Okay, my prefix is here, I have already told, and my suffix is where, and my suffix is here, S. Now I will increase, as I got matching, I will increase my prefix here, A, and A matching, then I will increase this 3 as 4, 5, 3, 4. Okay, now I will another increase suffix, I will another increase prefix. Okay, I will compare these A and A, I got 5. Okay, by this you can already feel I have already discussed the main part. If how you can handle if there is a mismatch, and how you can shorten the middle part. Okay, I have already discussed, and now I am going to the coding part, by which you can compare that how the algorithm works. Okay, so I am coming to the coding part. At first I will declare a vector of int. Suppose the vector name is LPS, and the size of the vector is what will be the size of the vector? The size of the string is dot size, and I will initialize all the element as 0. Okay, then I will initialize my prefix as 0. As you already know, my prefix will be here at first and my suffix will be here. So my prefix will be here and my suffix will be at 1. Now see one thing, my prefix, sometimes my prefix will increase or sometimes my prefix will decrease, but this is the suffix never decreases, the suffix ends here. Okay, and see, I have compared, when I am coming here, I have compared the whole string, so the output I will get from here, so I will return this output. Okay, so what I will do, I will run a while loop until my suffix goes to end, till the end of the string. Okay, and I will check if my element of suffix is equals to same element of prefix, then what I will do, I have declared the vector and I will push at suffix is equals to prefix plus 1. What I have done here, please notice that, compare it, my equal LPS of suffix. Suppose this is equal, so this here is my suffix, sorry, this a and this a is equals, so here is my suffix pointer. So LPS of suffix pointer I will put prefix pointer index plus 1, prefix pointer index plus 1. And what I have done, I have done prefix plus plus and also suffix plus plus, because you already know, because this consider this example ABC and ABC, my prefix is here, my prefix is here, suffix is here, suffix pointer is here, and I have matched this, and I will compare the rest of the element is matching or not. If it is matching, then I will also increase the prefix and also increase the suffix. Else, suppose this is not matching, else what I will do, I will check on condition. Suppose when I was checking this element ABC and ABC, I cannot go beyond this. I cannot go beyond this to comparison. I cannot compare this C to this because this ends here. So I will check one condition. If pre is equals to 0, then what I will do, I have gone beyond. I have the prefix at ends here, so I can put the answer here. So I have compared till it ends here, okay, and I have put it what the answer is. So I will put my LPS of suffix is equals to 0, means after comparison, if I am not getting any element, then I will put it as 0, okay, and I will increase the suffix. Always I will increase the suffix. Else, suppose this is not, this P is not 0, then what I will do, pre is equals to LPS of pre minus 1, okay. Why I have done here, because see here, see this element pre minus, this is the mismatch here, mismatch happened, C and D mismatch has happened. So I will check this one. So suppose when I was checking, this part is not there. I was checking, this is the mismatch here, happened here, and I am checking beyond this. So suppose this is not there. So if there is no element, so I can say that there is no common suffix or prefix, okay. See, suppose this mismatch has done here, and I have noticed that there is no more element, so I can put there here is 0, as there is no element to compare. So I have written here, if prefix equals to 0, then I have done LPS of suffix equals to 0, and I have increased the suffix and for further comparison, okay. Else, if it is not, then what I have done, I have done prefix equals to LPS of prefix minus 1. I know that I have done mismatched here. So I will find the previous construction before or not. So I have, for this B, I have come here to compare this construction B to B, and I found that there is no matching. So I will come at this B, okay. I will come to at this B and I will compare. So what I have done, prefix equals to LPS of, means prefix equals to LPS of prefix minus 1. So every time I will go to the previous element of the prefix, like prefix will jump here, prefix will jump here, like this. Okay, so this is your code, and I will simply return lps of is dot size -1. So this is all the code. Thank you everyone.
Yeah.